Hello, I'm Dr. Ian McCullough, and today we're going to talk about three very important concepts. The first is the difference between accounting, data accounting, and decision support. Data accounting and decision support. The second concept is the importance of data consistency. And the third is a framework or methodology for delivering data science and decision support to teams, which is the R.O.A.D framework, R.O.A.D. I'd like to begin by talking about several common myths about data that I see used widely across consulting. The first is that the data is going to tell you something. Data is not going to tell you something. When you hear a client say, I want to see what the data is going to tell me, that is a horrible approach. If we look at what the scientific method is, right? We talk about data science. It leverages the scientific method. The scientific method says, observe the world around you, form a hypothesis, collect data, then you test the data, and then you draw your conclusions. So when we're looking and saying, what does the data tell you? Well, it can help you form hypotheses. When you look at patterns in data and you conduct exploratory data analysis, when you look at a dashboard, those might trigger insights that then lead you to say, I think something's happening in this organization or in this business problem. But you need to identify what the issue is and then form a test, right? What's your hypothesis of what's going to happen? And then you go and you collect the data that you need. Collecting that data you need might involve repurposing existing data. It might involve accessing data that you've already collected, or it might involve an investment in collecting new data to answer your questions. And then that trade-off then gets evaluated based on the preferences of the client within the R.O.A.D framework. But the idea that the data is going to tell you something without any hypothesis, without any formal collection and test, is a myth. Another common myth is that I'll know what I want when I see it. There are cognitive limitations in human perception. In fact, there are only 7 pre-attentive elements of perception that you can display on a single visualization. You have the x-axis and the y-axis are forms of position where you can locate something. You can contrast two variables that way. You can color a data point, right? So you can have different colors, you can have different shapes, you can have different textures, you can have different intensities. There's a limit on the number of things that you can actually display in a single visualization. So in situations where a person is trying to comprehend more than 7 elements of data, then they're cognitively limited, right? They can't physically represent that much. And so when they're asking you to present to them more data elements to make a decision than is physically possible to display on the chart, they're never going to get what they want. Now, when we start dealing with 3D or when we start dealing with over time, right? You can have add things like blinking data points, right? You can add movement to the visualization. You can do other things which allow you to introduce more data elements. But the human mind is able to only perceive about 7 plus or minus 2 items. When you look at color spectrums, we can tell the difference between 7 shades of blue, but when we put those 7 shades of blue, intermix them with a bunch of other colors, our brain then has difficulty in actually making sense of those different colors. So it's not clear that if you add more than 7 items, 7 elements of data, that you're even able to cognitively perceive that. And so this idea of just show me something is inherently a lazy approach, and you have to really work through the requirements definition, perhaps explain to your client why there's a limitation cognitively on the ability to perceive too much information or too much data on a single display, and why you might need to have a couple different visualizations. More importantly, it's important to identify what decisions somebody's trying to make up front, and then design the visualization to be able to support those decisions that they're trying to make. And those decisions that they're trying to make is probably more than just the data. It's understanding what analytic, it's getting clarity on the requirement. And if you don't set those expectations upfront and early, you're going to fall in a trap of continual rework, you're going to drive up your delivery costs, and you're going to be very unlikely to satisfy your client at the end. Another common myth is that data is numbers. Data comes in all forms and sizes and shapes. Data can be numbers, that's true, that's numeric data. It can also be ordinal, right? When you look at Monday, Tuesday, Wednesday, Thursday, there's a certain order to those days, but there's no number inherently associated with it. Data can be categories, right? Like cat, dog, animal, fish, right? These are categories. There's no number associated with it. But data can also be in the form of listening to your client and understanding how they feel, getting some empathy with them, understanding what their challenges or pain points. Sometimes clients, they have this tacit knowledge they can't express, right? They can't articulate it. Being able to tap into that is also another form of data, and they're all equally important. We can sometimes apply mathematical structure to non-mathematical things, such as when we do natural language processing on words, to be able to do things like sentiment analysis, or to be able to do topic modeling or other applications. But these are, data is just more comprehensive than numbers alone. I like to use a 2x2 model where there is quantitative data and qualitative data. And then we also have quantitative methods and qualitative methods. And we understand quantitative methods applied to quantitative data. That's like statistical regression, that's math. We do a lot of that. We also understand qualitative analysis of qualitative data. Our digital studio does that quite a bit, where they get journey maps, they get client experiences, and they help derive insights that are very valuable to clients for that. But what about quantitative methods applied to qualitative data? Well, we can introduce that with things like natural language processing, computer vision. AI is ripe with those examples. We can even do things like cultural domain analysis, where you take a list of salient items that somebody lists as important about culture and convert that into a quantitative vector that allows you to better measure change over time, or just provides another insight into a client challenge or problem. We can also do qualitative analysis of quantitative data. What is that? When you do a dashboard or a visualization that shows numbers, but there's no statistical test, there's no math performed on those numbers, you're just showing like a bar chart of trends over time, that trend is a qualitative assessment, qualitative method applied to quantitative data. And that's quite frequent. We oftentimes place a judgment that quantitative is better than qualitative. Well, that's not necessarily true. I think all perspectives are important, but be careful that you don't mistake qualitative analysis of quantitative data for a quantitative method. The last myth I want to address is that you need to get all of the data. You don't have to get all of the data. There's this myth that before we can begin doing analytics, or before we can begin introducing AI, we've got to get our arms around all the data and make sure that it's perfect and make sure that it's all there and it's all in one place. And we've done this central data integration, we've moved it to the cloud, and only then can we begin doing AI. That is a horrible myth. In fact, when data is collected, it's often collected for a different purpose than your client's requirement today. And so what you're really doing, even if you get all of the data there, is you're repurposing it for another use. And it might be better to go out and collect a random sample, a subset of data designed for what you're trying to answer, or what your requirement is, than to try and repurpose perfect administrative data. Other times, the data is just not inherently there. If you look at COVID estimation, when we were trying to do integration from county public health offices to see how many people have been diagnosed with COVID, well, the reality was that half the people were asymptomatic and didn't even know they were sick, let alone get tested, let alone enter the data. They weren't even captured in the data in the first place. So when we try and run epidemiology models to understand the state of the pandemic, they produced horrible results because the initial conditions of those models were terribly inaccurate. If, however, we recognize that we not only don't have all the data, we can't get all of the data, we can take what we know clinically about a disease, we can create a model, and we can use that to estimate the data that we don't have and get much more accurate results for estimating and informing decisions. There are countless examples of where data does not have to be perfect, and you don't need all the data. In fact, the strength of AI and the strength of analytics comes from that very fact that I can use mathematical models and estimation and predictive analytics that don't require data, 100% of the data. And if I spend more money on investing in predictive analytics and less money in trying to get data perfection, I will actually have better outcomes and better decision support in the end. So the last myth is you don't need to get all of the data before you start applying analytics. I'd like to introduce a framework for addressing problems called the R.O.A.D framework, R.O.A.D. This framework has been found to set more clear expectations between client and delivery team. It informs a better backlog for analytic sprints, which drives down the cost to deliver and prevents rework and ensures that clients are satisfied with outcomes. So the R.O.A.D framework has 4 components: requirement, operationalized data, analytic methodology, and decision support. With requirement, the first thing we have to address with requirement is understanding whether our requirement or problem is one of data accounting or decision support. Many problems involve data accounting. How many prisoners are in the prison? Are our invoices accurate for whatever we're billing? Do we know how many soldiers we have on the battlefield deployed? These sorts of applications are very much about data perfection, high normalization, and we want to make sure that it's right. And that's one class of problems. That's not really what R.O.A.D is optimized for. Decision support is more focused on things of how many prisoners are we going to have in 6 months for that kind of forecast? What resource allocation do we need? Not how are my invoices going out for last month's expenditures, but what budget allocation do I need to estimate for next year? How many employees am I going to have given estimated attrition and success in recruiting? Right? These are kind of decision support that are important for making strategy, resource allocation, assessing risk, and they don't require data perfection and they don't require accounting. That's the first class of problems. The second issue when we're setting requirements is to define some hypotheses. And that is when we can do exploratory data analysis to kind of look at patterns, we need to convert those into hypotheses that we can test for and confirm in a confirmatory decision. Or we need to have a clear business understanding of what the use cases are that's keeping the client up at night, what their boss is going to require or expect of them, so that we can have a clear, tangible set of requirements that we are going to build analytics to support. There are many assets that you have for doing that. Our digital studio is great at doing service design where they can go out and get great empathy with the clients. They can go deep into the organizations and not just look at C-suite stakeholders, but actually get at the folks that are in the trenches doing the delivery and identify other potential issues or requirements that might support them. Part of human-centered design is not only answering the needs of the C-suite, but also meeting the needs of the users, or you're going to have issues with data entry and data quality. By defining clear requirements at the beginning of an analytic process, you guard against confirmation bias, which is the most important issue. Oftentimes, when people are setting analytic tasks, what they're wanting to do is they have this idea, this belief of what's happening in the organization, and they're looking for somebody to show them data or evidence that proves that their bias is correct. That's where that Mark Twain saying of there's lies, damn lies, and statistics come from. Well, that's a misapplication of statistics, right? And it's not really statistics. It is just looking at descriptive data and using numbers, misusing numbers to try and prove your bias point. If you can set a clear hypothesis that is testable, you can then follow the scientific process, which is you take that hypothesis, you then collect data that's designed to address that hypothesis, you analyze it, and then you draw your conclusions. And you may not like the conclusions that you draw. If you're not prepared to dislike the conclusions you've drawn, you probably haven't appropriately defined the requirement that you're trying to address. But getting clear buy-in from that client as to what the requirement is, what the purpose of your analytic effort is essential before you waste time and money in doing anything else. The next step in the R.O.A.D process is operationalize data. And this word operationalize is important. It's rarely the case that data is perfect. It's rarely the case that the data that you have in your organization was collected to inform this requirement you just made up. In fact, we have to operationalize the data, which might involve repurposing data we've already collected. It might involve collecting new data. It might involve transforming the data in some intelligent way. There is a cost in terms of time and money to repurpose, collect, or use data that you've collected in your organization. Data often doesn't exist. For example, with COVID-19, as I mentioned before, half the patients were asymptomatic and didn't even know they were sick, let alone get tested, let alone be represented as a data point. You can't go and collect that data point. It's unrealistic. There's also an issue with data consistency. Oftentimes when people are labeling data or entering data in the first place, there's all sorts of issues with quality. For example, experts, when they're making a determination on whether extremist forums are either pro-Al-Qaeda or pro-US, disagree over 30% of the times. Medical decision-making regarding things like organ transplant is incredibly heterogeneous and gets worse in the evenings and weekends. In fact, most applications where people label data for machine learning algorithms have huge inconsistency, and that inconsistency affects the precision. So for example, in an object detection task, if I'm trying to identify trucks, just the sloppiness of how people put bounding boxes around the trucks to train the computer vision algorithms, right, can affect the precision so that when I say it's a truck, it's a truck. The volume of data affects the recall. Do I find all of the trucks? But when you have an inconsistent labeler that's not the same as the other people that affects precision, when you throw the data away, you're affecting your recall and your performance of the system. But I would argue that if you don't address that consistency upfront and early, you start incurring technical debt in your solutions that you cannot easily recover from. So it's really important to get that consistency correct upfront and early. There's also issues with the quality of data entry. When I was in Iraq, we were talking about terms of reference. So when there's 128 elements of forensic evidence in a roadside bomb that goes off. And so then the question becomes, does a soldier that has just been ambushed and is worried about his friend that has been attacked, and is he going to get attacked, and all of the other things that are in his mind, are they able to keep their mind straight about the quality of data that they're collecting on that site? Let alone, how did they enter it, usually in a handwritten note, and then that's passed off to somebody for manual data entry later. You know, another problem is, do people feel vested in the solution? If you have people that you're relying on for data entry, but they're not getting anything out of the system, what is their motivation to actually put quality data into the system in the first place? Right? These are all issues that go into the quality of the data, the consistency of the data, and all of that is an important consideration when you're designing your analytic sprint. Because it's not even just, is the data right? Does the client even believe that the data that you are about to use or you're proposing, do they just believe to themselves, right, that that is suitable for answering the requirement? Because it's a shame if you define a requirement correctly, you get some good data, you do great analytics, you inform decisions, and at the end of the day, the client all of a sudden feels uncomfortable with the data that was used. If you don't operationalize it correctly and get client agreement up front, you're having a problem, and you're going to have rework, and you're going to have dissatisfied clients. Oftentimes when you're operationalizing the data and you start looking at some of these challenges with the data, it might force the client to redefine the requirement up front. It might require an earlier decision on whether they're going to invest money in getting the data better or just be satisfied with what they have. The A is for analytic methodology, and this is usually the most straightforward, simple aspect of analytic methodology. Because when you have a certain requirement or hypothesis generated, you have a certain data, the data and the hypothesis usually inform what's the right analytic to use. But it's important that you share that with the client of how you're going to take their requirement, their data, and turn it into insight, and make sure that they understand it. If they don't understand the algorithm or the data, they might want to revise the requirement. Lastly, the D is, what decision are they trying to make? What's the deliverable or action or result of what you're doing? And have you defined that up front? A lot of times I find that when I get to that point of trying to define the decision, a client's not comfortable making a decision based on the requirement, the data, and the analytic method that I've laid out. So then why are you investing in this project? It's important to get that resolved before you begin work. But once we've laid out the R.O.A.D of the problem, it provides an excellent backlog definition for an analytic sprint using an agile methodology, and it allows a much more focused delivery. It reduces the time analysts spend wondering what the real client requirement is, and it ends up resulting in an outcome that the client has already signed off on and already expects. I recommend laying out the R.O.A.D in a template that we have that kind of clearly defines it, and get the client to agree to that and sign off on that before we begin the analytic sprint. When we consider AI through the R.O.A.D framework, we can identify areas to ensure responsible AI delivery. Under requirements, are we eliminating confirmation bias using properly scoped requirements? Are we recommending data lakes and AI solutions when clients really need a data accounting solution? Or are we wasting resources on excessive data integration in an effort for data perfection when the requirement is really data science? Have we considered which steps to automate in a process and which ones should be manual in a human-machine solution? Under operationalized data, what bias is introduced in how we operationalize the data? Most bias in an AI solution occurs at the point where biased and discriminatory people are labeling the data, not in the algorithm itself. Under algorithms, do we have a sufficiently skilled data scientist to prescribe the right analytic given the requirement of the data, much like a physician would prescribe the correct medication or medical treatment? Or are we allowing unqualified analysts using low-code, no-code environments to be free to misapply analytics and create increased risks? Under decisions, how do we implement the decisions from an AI solution? When the solutions inform as opposed to making decisions, trust increases. So have we thought about where we're allowing the human to make the decisions or guide the process, where we've created intentional points in which humans engage in the process? What happens if you can show that a certain AI process has less bias than a manual one and creates greater equity at lower cost? Is it not unethical to fail to adopt AI? Looking at the R.O.A.D framework in a responsible AI lens allows much greater consulting in de-risking the process and ensuring that our clients are delivering the best possible outcomes with the available technology. We have covered several important topics. We have talked about the difference between data accounting and decision support, which is one of the most important topics to wrap your head around in consulting. We've talked about the importance of data consistency and where human biases enter a process. And we've talked about the R.O.A.D or R.O.A.D framework, which has been found to lower risk, lower cost, lower rework, while maximizing client satisfaction and OI. I discussed 4 myths about data. The myth that data will tell you something. The myth that I'll know what I want when I see it. The myth that data is strictly numbers. And the myth that you need all the data. In fact, the data won't tell you something. Proper data science applied to the data in a scientific process might tell you something. In fact, you can't know what you want when you see it because there are certain cognitive limitations in the brain that require you to plan ahead. And data is more than numbers. It involves those client conversations. It involves tacit knowledge. It involves categorical and ordinal data. And you don't need all the data. You oftentimes just need a subset of data that's customized for your application. And we've gone into detail about the R.O.A.D process, the requirement, operationalizing data, selecting the right analytic method, and ensuring what decision you're making so that you get early client buy-in, you have clear definitions for the analytic teams, and then you ensure efficient delivery of your data science solutions. I hope you found this informative, and I hope you go forth and make a great impact for our clients and their solutions.